So, David, in the first TED talk you gave, you had this phrase that you quoted really from Stephen Hawking. Stephen Hawking referred to humans as basically chemical scum on the surface of an obscure planet. And that's actually quite a common view of how science is thought of as treating humans. You know, we started thinking we were the center of everything, and then we gradually discovered that no, we're just a planet revolving around a star, and then that star is just one of 100 billion in a galaxy, and that galaxy is one of hundreds of billions of other galaxies. And goodness knows, we become very quickly completely insignificant. You, I think, disagree with that characterization. Explain
I do.
why.
And you're right, that's the prevailing view, because that's the view that's kind of forced on us by a narrow conception of what science is. According to that view, you classify things in the universe in a sort of hierarchy of more massive and powerful versus less massive and so on. And so we're used to the fact that the big objects like the supermassive black holes in the center of a galaxy affect a star, can rip a star to pieces, but the star being ripped to pieces hardly affects the supermassive black hole. And it's the same with the sun and the solar system. You know, the sun affects the Earth, but the Earth barely affects the sun, and so on. But the funny thing is, on Earth, on the surface of the Earth, everything's the other way around. Everywhere you look, you see the effects of life on Earth, and life, every living thing that you see is the result of the action of a single molecule, or two molecules or something, depending on what kind of organism it is. So this submicroscopic entity commands vast resources. Now, humans take this to a wholly different level, where we are capable of becoming cosmically significant, not just dominating the surface of a planet, but dominating the galaxy and further out.
Well, how so? You mean by kind of Star Trek-like exploration or something else?
Yes, Star Trek, or rather colonization. It's what we do. Humans evolved, unlike all other existing organisms, to find new environments which are initially lethal to them, and to change the environment such that they can live comfortably there. Here I am sitting in Oxford, and if it weren't for technology, I would die within hours, because without clothes, without shelter, without medical attention, without sources of food from far away, I would be very hard put to it to forage. And the territory here supported only a tiny number of people in the early days of our species, whereas now it supports tens of millions.
And so the difference between your survival and otherwise is human knowledge turned into technology which has built, you know, the house, the central heating, the clothes, and so forth that keep you alive.
Yes, fundamentally it's knowledge.
And I mean, when you talk about, you know, like that humans can have indefinite impact on the universe through Star Trek-like expansion out, like at first glance, a lot of people listening to that will say, well, already that's sounding a little silly, that's science fiction anyway, and how can that possibly mean much? But your whole second book, this idea of the beginning of infinity, is arguing that knowledge in principle has infinite reach. And therefore, if you don't include that in your worldview, you are missing out on something fundamentally important. So talk a bit more about how we could think of that reach of knowledge.
Perhaps it's more illuminating to think of this the other way around. So suppose there were some extraterrestrial beings, intelligent beings, looking around at the stars from, let's say, 100 light years away or something in the galaxy, and they would see various stars, and they might use astrophysics to predict what these stars will do. But on Earth, they would detect something, for example, the fact that there's oxygen in the atmosphere, which tells them that there's life here. And then they would detect, if they kept watching the Earth for a while, I mean, I'm kind of imagining them with technology similar to ours. They could detect more if they had better technology. But if they watched the Earth for a couple of decades, they would see that the mean temperature of the planet is changing faster than it possibly could. Only artificial intervention can change the temperature of the Earth as fast as it has been changing. This is inexplicable without the presence of intelligent beings. And if they then ask themselves, well, this influence, the influence that affected the atmosphere of that planet, could it possibly affect us? And the answer is yes, because the issue of whether a spaceship can get there is a matter of what we decide to do. And it's also a matter of the laws of physics.
So, David, I think it's important almost in having this conversation to, bear in mind that the way you think, by thinking in sort of theoretical terms about what knowledge might in principle one day do, that has implications for how we should think of human beings and our role in the world. And so when we talk about aliens or we talk about the potential for exploration, you're not saying that, hey, this is going to happen anytime soon. What you're saying is it is in principle possible for this species that has evolved on Earth to have a future that is imaginable. It may not happen, but it is imaginable, where it can become indefinitely more influential in our solar system, eventually maybe our galaxy, and maybe beyond that. And so it's that fact that that is possible in principle, which creates this anchor, this fundamental idea that knowledge, there's no limit to how powerful an influence it can eventually have, starting with Oxford and central heating and moving out, in theory, indefinitely beyond. And that is a remarkable fact that needs explaining.
Yes, you asked about the cosmic significance, so the answer that I give to explain it, in some sense, must involve things beyond everyday life. But everyday life, as we see it, would have been regarded as completely magical even a few centuries ago, let alone for the most of the period of the human species. For example, I can sit in Oxford and look a bit beyond my house and look up in the sky and I see an aeroplane there. Now, the fact that a metallic object weighing 100 tons is flying there at 500 miles an hour and has come from another continent, that is as much of a jump from natural human beings as what we're discussing, this kind of space travel, space exploration, is from where we are now. In fact, I think comparing those two, I'd guess we have already come further in terms of knowledge than what lies between us and space exploration. I'm not saying exploring the galaxy, that would require more knowledge, but that's all it requires. If you're a scientist and you're asked, is so-and-so possible? You have to use the laws of nature. You can't say, well, my intuition is that will never happen, because our knowledge of the laws of nature is far superior to our intuition.